Good morning and welcome to day 2 of Black Hat 2015. I have a couple of announcements. Stop by the business hall located in Shoreline A for sponsored sessions in Theater A and B. Be sure to check out all the Black Hat Arsenal and Breakers D, E, J, K. Sponsored workshops are in Mandalay JKL. You are in Lagoon K for the session CrackLord, Maximizing Password Cracking Boxes with Lucas Morris and Michael McAtee. I'd please ask that you put your phones on vibrate. Makes it easier for the rest of us to ignore the ringing while you wait for the voicemail to pick up. So, good morning, everybody, and let's welcome our speakers.
So is everybody surviving this morning? Yeah? Everybody's awake? I know there's a couple people that were half asleep when we walked in about 15 minutes ago. So wake up, good morning. So we are here this morning to talk about a tool. It's a methodology that Michael and I have put together here over the last year. Basically, we call this tool CrackLord. We thought the name was funny. He'll talk a little bit about it. We had some rejected names too, but you want to flip the... So basically what we want to talk about today is really 4 things. It's just a 25-minute talk. We're actually going to leave some time for questions at the end. So, we're going to be very brief. That being said, there are 4 things that we want to talk through. We want to give you a little bit of an introduction, right? What talk doesn't have an introduction? So that bullet point's probably a little superfluous, but whatever. We're going to talk about the intensity of resources and tools that we use as penetration testers and how, in effect, we are very lazy people. And we like being lazy. We want to, make sure that we are being efficient in the time we spend. Obviously, we're here to talk about a tool, so we're going to talk about the tool. And then we are going to have some demos. We decided not to do live ones, so sorry, we're going to have to stick with videos, at least for now, because we don't trust the Wi-Fi. So, who are we? Well, my name is Lucas Morris. Michael and I both work for a company called Crow Horwath. We're just an accounting and consulting firm. I'm a senior manager. I'm a manager in quotes in that I don't do a lot of managing, I do a lot of doing. So it's actually a pretty cool gig. And I am a pen tester by trade. So do spend most of my time actually breaking into systems. And I'm also a bit of a code monkey. So when Michael says jump, I need you to write this, I tend to disappear for a few weeks.
I'm Michael McAtee. I am a manager at Crow. I spend about half my time doing pen tests, and the other half doing sysadmin work. I also run our labs where we do our assessments, research, testing, all that stuff out of. So besides doing some of that for clients, I also do it internally for all of us. And then I'm not creative enough to think of something funny, so please insert your own joke here.
Okay, so let's talk about why we're here. First question, how many of you have a GPU cracker? How many of you wish you had a GPU cracker? And how many of you have a GPU cracker that's a pain in the butt to manage? People, collide on each other. People are, stopping each other's jobs. They're overriding each other. Yeah? Okay. Well, so did we. And in fact, that's why we're here. But before we talk about cracking, we actually want to take a step back. So one of the things that we have found here over the last few years, especially with Michael running the lab, the assessments that we're doing, and the work that we do for our clients, is that we are starting to create purpose-driven resources. GPU crackers were the first, but we now have a lot of dedicated resources in our labs to things like processing ntds.dit files, running nmap scans, and other things that they exist solely for that purpose. And in a lot of cases, we do have issues with managing them. So we have this purpose-built hardware. But how do we manage that, right? How do we make sure that people are able to use it together? So, we're not really sure if people are sharing, because I'm sure you have that guy like we do that if he wants to run something, he just kills everybody else's stuff, makes it go, right? We have the guy that, he didn't quite run it right. You have the intern that didn't run it, and it's not resumable. So what am I supposed to do? He's running a crack of every password on an AD domain for some audit, and I just cracked a workstation that's got a DOM admin logged into it, and I need an MS cache password now. Well, if he didn't make it resumable, can I kill that? Maybe not. So sometimes we also, we don't really know where the output is. Again, see the intern problem, but people write stuff all over disk. They've got stuff in home directories. Maybe if it's Hashcat, they've got it all in the Hashcat users so that we can run X. We're running on top of each other. It gets really odd. So For us to share, we had to break some rules. Michael runs our lab, so not only we have to break some industry rules, we had to break some of his rules. And he's not the type of person you want to piss off. So he whines a lot and makes you regret breaking his rules. So, what did we have to do? Well, we had shared accounts, right? We don't like to do that, but everybody had to SSH into our GPU cracker or GPU crackers with the Hashcat user. Why? Well, we needed X11 running. We needed Xorg running. So they had to use that. We had to have a shared password. We had people start stuff in a screen. Hopefully they put their name on it so you know who to talk to in the event you need to pause it. And frankly, we had to do manual data cleanup a lot of times because, I know as in general, workers, well, we don't do a good job of cleaning up after ourselves sometimes. So, we had a process as lab admins where we'd go through and clean up data because we didn't want things sitting out there for our clients. And frankly, we're not even sure if people use the right options. Can we even resume it? We had some problems with that. So the last piece is we spent a lot of money, right? We have multiple GPU crackers. We have a lot of big boxes in our lab. Some of them are running VMware. Some of them are purpose-built. And, well, sometimes this box was sitting idle. Management thought we had a nice, expensive toy and really didn't know how much we were using it. And, are we using all the resources? Our GPU crackers have really powerful CPUs. We never touched them. We never really thought about what we were doing with them. So, with that, our solution is CrackLord.
Right. So our solution is CrackLord. It is a distributed system intended to solve these problems for one or more of these dedicated systems. The input and output mechanisms are generic. We have a schema to follow to make things easier so that it's easy for a plugin to generate a form and to spit output out in a standard format that people can parse and use. But generally, the tools are free to do whatever makes sense for the tool. Because obviously, if you're, say, running Nmap, the output of Nmap is going to be a lot different than the output of Hashcat. Or if you're parsing an ntds.dit, that output's going to be a lot different than, say, Nmap or John or Hashcat, whatever it may be. We also thought a nice feature to get a couple, some outside people involved. We don't use this one internally, but having some ability to spin up cloud instances, especially the ability to maybe spin up a cloud instance just for a little bit for that really important job that you need to run. And then finally, the whole thing is based on a RESTful API, and we're going to show you in the demos our GUI, which just calls that API. But if you have existing workflows, automation, scripts, tools, whatever that may be, there's a RESTful API that you can tie right into, connect in, submit jobs, pull the data out. So you can, and that's documented as well on the GitHub page. So if you want to write your own automation stuff, it's there for you to do. So the first two components of this system are the queue and the API. And this is what people using the system are going to see. They are going to either be using the provided default GUI, which is an Angular website, or they are going to be using maybe some script or something custom written that hits the API and is communicating with the queue. And the queue manages everything else. It keeps track of the jobs, it stores the results, it stores what you submitted, and lets you do some nice things. For instance, pausing and resuming. So when you have that individual who really needs to run a crack right now and other people are using the resource, they can drag theirs to the top, pauses everybody's jobs, runs their job. When it's done, picks up and resumes. And because no one is dropping their own command line arguments into Hashcat or whatever it is, they're all controlled by the plugin. You can make sure that they're doing the right thing so their job is resumable and they're regularly saving state so that when you do pause it, you don't lose too many guesses. As we said, API is extendable. Every tool kind of sets up its own thing. You'll see that during the demos. And then the queue communicates with everything else through TLS, and it is mutually authenticated. So that connection where you are going to potentially be sending sensitive data to your resources, that's going to be over a mutually authenticated mechanism that either our default installer packages will generate for you, or if you have an existing PKI environment, you can set up your own certificates. The last two pieces of the system are the resources. Now these are those dedicated pieces of hardware, the GPU boxes, maybe a box for Nmap, whatever this may be, VM, physical hardware. This runs on that and manages the resources, or manages the the capacity you have there, be it CPU, GPU, maybe some custom ASICs. It does work both on Windows and Linux as far as our testing has gone, and that has been our goal so far, so that if you do have something, maybe a Windows tool that you need to run on a Windows box, you can have a resource running on that Windows system to execute that. The tools are where you can write your own. These are the extensible pieces. Right now they're written in Go, they're Go packages, and that usually wrap some kind of external tool, but you could also write a Go package that just is a Go package to do some kind of task. You set up what parameters you need the user to provide, and you set up the format that you return them to, and all you have to do is implement 5 functions that are pretty simple: run, pause, quit, a way to get to your standard in, standard out, and I think there's one more. This is why we document. And so this is the overall design, and as you can see, we have users who talk to the queue. Queue then manages several resources, which may have some number of tools running on each of those resources. If you have identical tools between resources, it shows up once in the queue, so you submit that and it goes to the first open resource. As far as authentication, right now we have standard just 3 user authentication with 3 group levels, one of them being administrator, so the admins, the other being a standard user who can run cracks but can't manage resources, and the last one being read-only. So if you have scripts that are pulling statistics or maybe collecting data in an automated fashion, you can give it a read-only account for that purpose. We also have included an AD authentication module because that's what we use internally in our labs. So if you want to tie this into AD, it does work. And now, demo time.
We prayed to the demo gods. Hopefully our videos work. Okay, so you can see here the default GUI. And basically this is what a user is presented with. So we put in a name for a tool or for the crack itself. It will track who's using it, so you don't have to do that, but this is where we put client name and other things. So what you will see here is each tool does have the ability to present a form. This is all agnostic. There is a standard schema that we use, and each tool gives this. So the GUI, the queue, the resource data really don't care. It's the tool that processes and presents this form schema. We just display it, process it out to some bootstrap. So what's nice here is each tool can ask for drastically different things. In this case, Hashcat we have configured to allow both dictionary attacks and brute force attacks. So we are first going to, of course, give it our hash type. We're going to select our dictionaries and other things. We are going to put all of this in, and then we will click Go. The hashes, for anybody that cares, for those playing the home game, the usernames are, in fact, the passwords. So please feel free to crack at will. We just generated them. So once you hit Submit, the job is immediately created. You will see a couple of things here. One, we just have a single job. It does take a little bit of time. There is actually a process internal to the queue. It is now sending stuff off to the resource. The resource is going to start it up, and eventually what you will see here is, as it just did, we now have statistics running. How many jobs we completed. You will see the little play button kind of appeared, and we have everything we need. You want to jump forward? Yes. So we can also actually look at detailed statistics of the job. Again, this is all agnostic. The tool decides what it's going to present. We do have data over time, which if Michael skips ahead a little bit, you will start to see a graph build. It will update for you. So on some of our long-running jobs, you will see Hashcat, Nmap, other things. Their process goes up and down. It's actually kind of neat to look at. You'll also see we have the results here at the bottom. And you can export those out to CSV if you do want them, so that it's just, for us, at least on our jobs, we will come in, you will have 10, 15 jobs from our teams all running, and everybody can kind of see, come in, click exactly what their results are, where they are, what they need to be doing. So, similar to what we just went through, we also can, of course, add multiple jobs. With multiple different types of tools. So each tool says, I use this type of resource. It's just a string in the code. And it says, I use GPU, I use CPU, I use network, I use whatever the person writing the tool wants to configure. And what the queue will manage is, it will say, okay, well, this resource server has GPU. So I'm going to let one GPU tool run on it at a time. In the case of our GPU crackers in our lab, well, those have some pretty powerful CPUs as well. So we will actually let CPU and GPU jobs run on those. So you will sometimes see lots of different things running. I'm going to skip ahead just a little bit. Where did that?
Jump to the next one here.
Yeah. More importantly, as we said before, each tool can also take many different types of things. So you will see here, for Nmap, we have one type of form that asks for, different pieces of information. This, video just kind of goes through the different types. The GUI is very straightforward. We tried to keep it simple. It hides a lot of logic, which sometimes can be something that people don't want. But in general, we have found, especially with our teams, that this has actually been better. At first, people were frustrated that they couldn't go in, run the exact flags they wanted. But when they started to think about it, they realized, well, they didn't really use a lot of those flags anyway. So what you'll see here is this, at this point, is connected to multiple resources. Each one is given a color. And so you can see we actually have three Nmap scans running on 3 separate boxes here. They're all running simultaneously. They are all managed and are all actually running.
I don't use a Mac if anybody's picked that up.
So we also do allow people to reorder jobs. And it is simple as drag and drop. So you drag and drop, you confirm, the system will pause every job, and then it re-evaluates the entire list, the entire stack of what needs to be run. So in this case, we drug a job up, we hit confirm. At that point, the system made a request off to the queue. The queue stopped every resource, and then you will actually start to see here in a minute that the other jobs will start back up. They will pick back up, and it will evaluate. So if you have 3 or 4 resources, yes, things do stop, but they will all pick back up where they are. All of the tools that we have written thus far do support stopping and resuming of the jobs in place. It's very nice. And here you can see now the very top job started back up, or it started. Once this one finishes, we won't make you sit through the few hours that it's going to take to run through that dictionary. It would actually, again, move on to the next one. So we can reorder as much as we want.
Yeah, just to show you the resumption that works. See, we dragged a job that had been paused up to the top, and now it's resumed, picked up from where it left off.
So the last piece here, and this is something, as Michael mentioned, we don't use internally because we do have the resources that we need. But we understand that not everybody has access to a GPU cracker. And we actually do have some clients that have started to use this because of the way it provides them access. So we actually wrote the ability to spawn AWS instances in the tool. So you actually go to the resources area at the top. It says add resource. You can actually direct connect to one, or you can simply say Amazon Web Services. From there, you get this nice form. It looks kind of familiar to the tool one, right? Same schema, same everything. And you pick your subnet, you pick what type you want to run, and you actually pick how many. So you can spawn as many different instances as you want. And what will happen is, on the back end, the queue will start a service, will start a go routine that starts to listen. It pings AWS every 60 seconds saying, is this instance ready? Is it running? And our instance, we actually have an AMI we've put out. It's a community available. It's on US West 2 right now. We will probably copy it over to other places. That does actually have Hashcat, John, and Nmap pre-configured with some basic dictionaries for you. So it will spawn that. If you want, you are welcome to load the instance, customize it. There is actually a config file you can use to change the ID of the image that you would like to load. So what will happen is, and we're going to have to skip forward a little bit here because it can take up to 5, 6, 7 minutes for an instance to become available, is it connects. And you can actually see here, we spawn 2 instances. We have one that's direct connected, and then we actually have 2 that are pending. And what will happen is this is checking in, it's checking in, and eventually we get to the point where, if we did the video right, they are now running. So now all 3 of these are available. All of the jobs, anything that was sitting there, well, every 30 seconds a loop runs. It will see available resources, and it will immediately start adding the jobs based on the stack order. We do also, this is something we're still working on a little bit, but it will also remove the instances if they sit idle for a certain period of time. And by default, we do have that at 15 minutes because those G2 GPU instances can get a little expensive if you let them run for a while. We found that out while testing this. So, whoops. So, that being said, we've got about 5 minutes left. This is our tool. We hope you guys end up using it. It is available on GitHub. But really, there are kind of 3 major things we wanted you to take away. It's very extensible. So we have some tools written right now, but realistically, if you can wrap it and go, you can run it on a command line, you can put it in this. Now, some stuff probably doesn't make a lot of sense, but anything that's going to take time, that's really where we see this being useful, right? Nmap scans, processing large, like NTDS, AD database files, cracking passwords. That's where we are using this internally, and that's where we have found a lot of value. It frankly lets you kind of maximize the hardware investment, so we will put cracks at the bottom of the queue and the stack that just run whenever it's got empty space to get stuff done. It's actually quite nice. And the last thing is, plugins are awesome, so if you guys have any you'd like, put an issue on GitHub, we'll do our best, or send us a pull request. We like those even better. Those come with hugs when we see you next. And come on, they're worth it. So, here are the links. We have tried to document this as much as we can. So the github.io page actually has instructions on how to install this. There are deb files, so it is literally as simple as apt-get install cracklord-qd and cracklord-resourced. It will automatically generate certificates for you. It will get everything installed if you have it all in the same box. If you have multiple resource servers, you will have to generate your own certificates, but we also have some information on the wiki on this GitHub page that will try and help you through that. So if the documentation is poor, yell at us. We'll do our best.
Yeah, and please find bugs. Next few weeks, give this a try. Let us know what's not working. We try it internal, but you look at this long enough, you get into your patterns. Maybe you don't notice that it doesn't do one thing that most people are going to use, or maybe we used it a little differently internally. So we'd love to see you, other people go, spin this up, let us know what's not working, so we can work on making it better and getting it running as smoothly as possible. With that, we wanted to leave a little time for questions. I think there are mics here in each row. If you have a question, anything, feel free to jump up, and if not, we can meet you outside if you don't want to ask it in front of everybody. Yeah.
First of all, I just want to say, great tool. I think it's filling a need that's, we sorely need something like this. So, you mentioned before you were able to drag and drop jobs to see which one is currently active. Mm-hmm. Is there any support for concurrency between jobs? For example, I know Hashcat supports like the -d parameter, so you could address certain GPUs. I was wondering if there's any inbuilt support for that, or if it could be extended.
So. Yes, it could. We actually, in the config file for Hashcat, we actually have a place to just add your own arguments by default. During our testing, we actually had a bad GPU, and so we had to use that to avoid using that. The only thing it doesn't support right now, but we have an idea of how to implement it, is if I have one box and maybe I have 4 GPUs and I want to run 2 jobs on 2, right now it doesn't support that directly. Although you could kind of hack around that by making that 2 resources, running it twice, and then doing the -ds in each of the configs. So you could make it work. It's not as easy as, hey, just run it on these GPUs and then run something else on what's left if it's only requesting that.
Great, thank you.
Yeah.
Any other questions? All right, well, have a great morning, everybody.
Thanks, everybody, for coming out early.